Hello. So right now I'm going to do this example. Okay, I want to solve this quadratic equation. We want to find the x, which satisfies x squared plus 5x plus 6 equals 0. Now, as you all might imagine, what we could do is we could try to factor it. And in fact, if you think about it for a few moments, we could ask ourselves, can I find two numbers which multiply to give me 6 and which add to give me 5? Well, my choices are very limited because 6 is basically 1 times 6 or 2 times 3. Well, 2 plus 3 equals 5. So if I wanted to, using what I just mentioned, I could say, aha, it's likely factorable as x plus 2 times x plus 3 equals 0. I mean, well, forget about that part for a moment. Like this left-hand side is likely equal to that. Let's verify that real briefly, okay? X times x is x squared, right? X times 3 is plus 3x. Plus 2 times x is plus 2x. And then finally 2 times 3, and they're both positive, so it's plus 6. And when I combine these two like terms, I get x squared plus plus 5x plus 6. So indeed, this expression on the left-hand side of this equation can be factored as x plus 2 times x plus 3, okay? And so therefore, setting this equal to 0 and using the zero product property to say, okay, if I have these two factors, these two numbers, right, multiplied to give 0, then either this one is 0 or this one is 0. They're both 0, and then you get the x equals negative 2 and x equals negative 3 as the solution of this quadratic, right? Now, I know I did that really fast, but that's only because I wanted to get that behind us. Because this video is going to be focused on using the quadratic formula. And now we already know the quadratic formula works, okay? We know that starting with a general quadratic, we were able to use the completing the squares to show that algebraically the quadratic formula should work. And in particular, in an example like this, where we can already factor it and we can solve it that way, we're going to use this as our first example for solving a quadratic with the quadratic formula, because it's a familiar problem with solutions that'll appear familiar to us. After this example, we're going to do a couple that are slightly more complicated and more suited to solution by quadratic formula, and which are not suited for solution by factoring, okay? And let's get started with that. Now, the quadratic formula says the following. If ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now we're going to look at this equation here. We can see that it in fact matches the same form as this equation here. In particular, one of the key things that I want to mention to you is, as you notice in this example here, this equation in the let's call this our index card, this equation is equal to 0, and this one is also equal to 0. Okay, if it had not been equal to 0, if instead it had been like equal to something like, let's say 3 or something, okay, it would not be in that form, and we would have to put it in that form first to use it to solve this equation. But it is in that form, right? It's like this. So now, out of an abundance of caution, what I'm going to start by doing is I'm going to start by listing what my A is, what my B is, and what my C is. So my A, as you can see from over there, is the coefficient of my x squared term. There is no number visually indicated here, but we know that that's a shorthand for there being a 1 there, okay? One of the common mistakes a lot of students make is that they think that the x is 1. But what is really and so that's a confusion. They confuse me saying that a is 1 with the x itself being 1, but that's not what I'm saying. What I'm saying is this: if I have an x squared term like this, that is shorthand, okay? That is shorthand for 1x to the 1x squared. Okay? It's just that because this shorthand is justified because, for example, if I have 1 times 3, I get 3, right? So, for example, if I were to write the number 3, that would be the same thing as 1 times 3, right? Because 1 times 3 is 3, but we would not write a 1 there. Now, of course, in this case, in the case of numbers like this, it doesn't make sense to think of it in this way because we would always just write 3. We would never think of writing 1 times 3, for example. We would just think, oh, the number 3, the number 5, the number 100, whatever, right? But of course, in the case of algebraic expressions, we have to keep in mind what the numerical coefficients are. And so in the special cases where the numerical coefficient is 1 or -1, we don't usually write the 1 down, okay? So for example, just to tie that up or wrap that up with a bow or whatever, if I were to write -x squared, that's also a shorthand for -1x squared, okay? So therefore, going back to the problem at hand, we have identified our a. The coefficient of the x squared term is 1. The coefficient of the x term, which is the b over there, here is 5. And the c, the constant term at the end, you see? That's going to be 6, okay? And so now what we're going to do is we're going to start using them in the quadratic formula. So I'm going to say x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, one of the things that I want you to notice here is that I'm writing my formula first before I plug everything in, okay? And the reason why I want you guys to do that as well whenever you're doing a problem like this is because that will help you to, first of all, it'll help you to drill that formula into your brain so you don't even have to think about it. So it'll just pop out correct every time. Number one. Number two, because it'll serve as a template for you when you're going to solve the quadratic so that you can figure out where the numbers go. And finally, it'll just be a more effective study tool when you're studying for exams if you use your notes and all the details are filled in like this. Okay? Okay, so now I'm going to start plugging in the numbers, okay? So I have negative 5 plus minus the square root of 5 squared minus 4 times a times c all over 2 times a, which is 1. Okay. Now, let's address some questions here. What is 5 squared? 5 squared, by definitions, means 5 times 5, okay? What is 5 times 5? That's 25, okay? Now, what is 4 times 1 times 6? I know that this is equal to, remember, whenever I do the multiplication, I go left to right. 4 times 1 is 4. So this becomes 4 times 6. Okay. Oops. Now what is 4 times 6? 24. Right? And of course on the denominator here, 2 times 1 is just 2. So I can rewrite this expression as negative 5 plus or minus the square root of 25 minus 24 from the calculations we did here, and then divided by 2. Okay. Now, as you all may realize, 25 minus 24 is 1, and so this becomes negative 5 plus and minus the square root of 1 over 2. Now I ask myself, what is the square root of 1? The square root of 1 is 1. Right? So the square root of 1 is equal to 1 because, let's not forget why. because 1 times 1, or in other words 1 squared, is equal to 1. Just as, for example, the square root of 4 is 2 because 2 squared is equal to 4. In other words, what I'm saying is here, I don't ever want you guys to forget like the basic simple ideas captured by these like the basic simple ideas captured here. The square root, in other words, is the opposite of squaring. Since 2 squared equals 4, the square root of 4 is equal to 2. Since 1 squared, or in other words, 1 times 1 is 1, the square root of 1 is 1. Okay? Anyway, having said that, this becomes negative 5 plus or minus 1 over 2. So now we're in business. Once we're here, we can evaluate it both in the addition case and in the subtraction case. And that'll give us our two roots. Okay? Okay, so let's do that here. Okay? So negative 5 plus 1 over 2. Okay? Or negative 5 minus 1 over 2. I believe that might be the ugliest one I've ever written. But we're not going to worry about that right now. Now what about this one? Negative 5 plus 1, that's negative 4, divided by 2 is negative 2. Negative 5 minus 1 is negative 6. Negative 6 divided by 2 is negative 3. And if you recall, so in other words, what I'm saying, oh, whoops, I miswrote that, forgive me. Okay. Okay, so what we have just found is that the quadratic formula gives us, as the solutions to this quadratic equation, negative 2 and negative 3. Now, if you will recall from earlier, okay, if you recall from earlier, let me see here. This had been factored as x plus 2 times x plus 3. And so now we can set that equal to 0. That implied that either x, well, I don't have to write all the parentheses now, x plus 2 equals 0, or x plus 3 equals 0, right? And that implied, if I subtract 2 here, I get x equals negative 2. And if I subtract by 3 here, I get x equals negative 3. Okay? So in other words, look at this. The solution we would have gotten from factoring, as we had mentioned before, is precisely the same solution that we get from the quadratic formula. Of course, this should not surprise us, but it helps to see. It helps us to see that that the quadratic formula can be used on quadratics that are factorable. But that, of course, in a case like this, factoring is easier. It's easier because it's very clear. But as we'll see soon, there will be quadratics where we won't be able to factor, and that's where the quadratic formula will really shine. But in other words, this first example has served its purpose in showing us that we can actually use the quadratic formula even when the quadratic might be factorable, that we will get the same results, okay? And let me see here. Do I want to do anything else? And with that, let us move on to the next problem. Okay. And if you guys want, you guys might want to plug in these values into the original quadratic equation, into this quadratic equation, to see if they make the quadratic equation true. So for example, if I take the negative 2, okay, and I square it, I'll get positive 4. If I take the 5 times the negative 2, I'll get negative 10. So I'll have 4 minus 10 is negative 6, plus 6 is 0. So if you write that out and you also test it for negative 3, you can verify that these are in fact solutions to the equation. That is to say, they are values of x that make this equation true. I hope you all have enjoyed that, and I'll see you soon. Thank you.